Hello, everyone, and thank you for joining us today for our webinar on Rethinking Your Private Cloud with LeoStream and Fairbanks. Please note that this webinar is being recorded, and we will make that available via our website for you later. My name is Karen Gondoli, and I'm the CEO of LeoStream, but I also head up our product team, so I'll be taking you through the LeoStream portion of our discussion, including the demonstration at the end. I'm pleased and very honored to be joined by Mickel from our partners at Fairbanks. You'll hear more about and from him here. There he is. You'll hear more from him here in a few minutes when we get started on our topics for today. Those topics include what you see here. First, I'll very quickly talk about why we at LeoStream truly believe now is the time to think outside of the VMware and Citrix Box when it comes to building your VDI solution. I'll then hand it over to Mickel to cover the topics he's an expert at, namely why you should use OpenStack and other open solutions to build your private cloud. After that, I'll do a quick discussion on when you may want to consider expanding your private cloud into a hybrid cloud, which will lead me right into the demonstration, which is going to show LeoStream managing VDI workloads in a hybrid cloud comprised of Fairbanks OpenStack and AWS. When all that is said and done, we'll wrap it up with a little bit more about our companies, so you know how and why to follow up with us afterwards as you move forward on your private cloud journey. Now that's a lot to cover, but our plan is to do so and leave some time at the end for questions. If along the way you think of something you'd like to ask, you can enter your questions into the question fields in the GoToWebinar application, and we'll cover them at the end of the presentation. Now, diving right in. So why is now the time to think outside of the standard VDI box? Well, VMware and Citrix have dominated the VDI market for years, and their solutions are very good for certain workloads. But good as they are, over time they've become bloated with features that have made their legacy stacks complex and expensive. And their full stack solutions weren't originally intended to function as a private cloud. Instead of building something new, they've tried to wedge their technologies to work in a cloud model, and that has made their solutions unwieldy. Now, you know a cloud model is different from standard VDI. Among other things, using a private or public cloud allows you to provide on-demand capacity for users, allowing you to expand and contract your cloud to meet your users' needs. So if you're building a private cloud, you need to look for new technologies, ones designed specifically for cloud workloads. Thankfully, those technologies, like OpenStack, have reached a level of maturity where building your private cloud doesn't need to be daunting. And not only are those technologies mature, they're also open, which tends to be quite the opposite of those legacy VDI stacks. They lock you into their stack. So by building your private cloud from open components, you can design a solution that works best for all your needs, from VDI to containers and even more. Now, to talk to you about how to do that, I'm going to hand it off to Mickel.
Thanks, Karen, for the introduction. So my name is Mickel. I've been working for Fairbanks for quite some years, and I've been involved in the transition from a traditional ICT company to a private cloud OpenStack company. So until 2010, Fairbanks was a VMware service provider, delivering services around the VMware platform. But back then, we saw that competition became fiercer, and we decided to look into the possibilities to offer a unique proposition delivering the same service we did with VMware, but then with an open cloud platform. So that's what I'm going to talk about. And during the presentation, if you have any questions, feel free to let me know. So I'm also active on LinkedIn and post tech articles once in 2 weeks. Articles range from cloud strategy guides to topics about backing up cloud or possibilities to fall back from private to public cloud or vice versa. So if you would like to join me on LinkedIn, I'm happy to accept your invitation. And also, when you have any questions later, you can ask me via LinkedIn or via email. So the need of private clouds. In our opinion, in the Fairbanks opinion, there will always be companies which will not transfer their IT infrastructure to a public cloud. Reasons per company and, for example, can be different per company. For example, it can be because security privacy requirements, speed, scalability, or just simply the need to know where the data is stored. So another reason could be pricing, not unimportant. A couple of weeks ago, I shared an article on LinkedIn about Apple cutting AWS spendings by almost half in 2018. And also in the article was that Apple was partly motivated to run more of its own cloud operations to save money, a decision some other large users of cloud services like, for example, Dropbox also have made. So whatever reasons these companies have to choose a private cloud strategy, the next step is to select a private cloud option that fits your business model best. You can do this, for example, with solutions like VMware, we all know them, Microsoft, Nutanix, Citrix, Simplicity, and these are great solutions, but create a massive vendor lock-in and also have constraints in developing your company the way you would like to. So, for example, advanced tech companies and SaaS providers often have the need to adopt their software into the cloud solution and offer automated services to their end customers. Doing so, they need an open API with the cloud solution. And with, for example, VMware, there's no option to do this to your software clouds. But with OpenStack, it is possible to adjust the cloud just the way that you see fit for your business. An example of this is our customer Vincent in New York. They used the OpenStack cloud solution to build a customer portal for web and mobile solutions, providing customers with unique functionalities. Some more examples I will show later on. So what is OpenStack in a nutshell? OpenStack is a cloud infrastructure within your own data center, managing and orchestrating massive pools of compute, networking, and storage, and also providing solutions like backup, cross-hypervisor replication, for example, suited for resilience or automated migration, virtual desktop infrastructure, and more tools you need running your business. So the cloud infrastructure is completely software-based and configured on commodity servers and open network hardware. This simplifies the hardware architecture and contracts needed because it exists of commodity hardware and open switches, which is really clear what contracts you have. So there's also no need for some storage units and contracts anymore. A little later, I will show you a simplified drawing of an OpenStack cloud infrastructure. So one of the main reasons for companies to move to public cloud is because they don't want to manage their own infrastructure anymore. The cost of staff is rising, finding staff is difficult, the infrastructure is growing all the time, and so on. So companies think managing the infrastructure is a hassle, and they do not make any money doing it. And with OpenStack, you can have a private cloud set up in days and hand over the management of the infrastructure to a company like Fairbanks. So in this way, you can be your own Amazon Web Services with the benefits of both public and private clouds. Also, the adoption of new techniques can be sped up by having knowledge guaranteed by an external company. In the old days, when you choose to have new technologies implemented, you needed to set up IT teams to create a plan, schedule time, order hardware, and then initialize a configuration project. And with Amazon Web Services, for example, it's different because you choose to work with, for example, container technology like Kubernetes, and you can do so by clicking one button. And with managed private cloud infrastructure with OpenStack and Fairbanks, the same process is done as with Amazon Web Services to activate the new technology, but then in your own data center. So again, managed OpenStack is very comparable with public cloud environments and services. So nowadays we see that companies are looking to leverage their OpenStack environment by adding more and more functionalities. Virtual desktop infrastructure is one of these, and LeoStream offers a solution to use your private cloud infrastructure to also manage your desktop environment. A market, of course, dominated by VMware and Microsoft, but with proven alternatives. And that's why we are here today, of course. A little bit about Fairbanks. We are a company based in Amersfoort, in the center of the Netherlands, and we have been active with the OpenStack platform since 2009. Since then, a lot of functionalities have been added to the cloud, making it a serious alternative to Amazon Web Services, Azure, and VMware. From our office in Amersfoort, we manage customers from all over the world, based in several countries in Europe, like, of course, in the Netherlands, but also in Germany, Denmark, Spain, Sweden, and also outside of Europe in the United States and Asia. I always like to say that we are a small but a very brave company, which also, of course, makes it fun to work for. So for these customers, we implemented OpenStack infrastructures and took over the support by offering 8x5 or 24/7 managed services. With the managed services, we make sure that the customer's infrastructure is up and running all the time, and they don't have to worry about their own infrastructure, and they don't have to manage it themselves. So we do this by executing daily checks, implementing improvements, patches and upgrades, and by strictly following the agreed service level agreement, of course. With a standard OpenStack implementations, companies have everything they need to orchestrate and manage their servers, their storage, and their networks. And as mentioned before, additionally, options can be added to extend the functionality of the cloud, like with, for example, LeoStream, of course. And the cloud is built up by shared services. And in the next slides, I will show you some more how this cloud is built and what the different services do. It's a very simplified picture. So if we look at OpenStack, these are the standard OpenStack shared services. At the bottom, you see the hardware layer, which consists of commodity hardware. So, for example, customers use HPE, Hewlett-Packard, Supermicro, but also Dell Power Edge services we see a lot, and even in some test environments, Raspberry Pis, but please don't use these in production. It's not advisable. So that's the commodity hardware we're talking about, the standard servers. And if you look at the servers on top of that, the storage is also configured with the commodity hardware. So everything the stack exists of is commodity hardware. So although you are able to extend your environment with, for example, NetApp, FAS, AMC, Equalogic, Compellent, or other storage equipment, because all the major vendors support OpenStack. So within the hardware, the OpenStack platform is configured, providing you with the compute, the networking, the storage, the orchestration, and the management, just like using Microsoft Azure or Amazon Web Services. And on top of this compute layer, you can use your service configured with Windows, Linux, and several hypervisors, which make use of the storage and the network platform provided by the infrastructure. And the operation of the OpenStack Cloud is done from the dashboard. It's a secured web page where you can log in at any time, any place. Oh, here come the raspberries. Yeah, Trilio did that in a really nice way for me. Beautiful. So additionally, options can be added. For example, Trilio for advanced backup and restore. For example, HiStacks for machine migration, automation, or advanced failover and failback from your own private cloud to a public cloud, or from a public cloud to your own private clouds. Several options are possible with that. But of course, also with Kubernetes for adding containerization, and of course, LeoStream, what we are talking about today. And also, last but not least, quite important, everything else to which you can connect to the private clouds using an API. And we see that a lot of customers of ours, a large percentage of our customers, create a unique business model with developing their own features and technologies as add-ons to OpenStack, and they do that to keep ahead of their own competition. That's one important reason to choose for OpenStack. So with this said, with the endless possibilities of OpenStack, no boundaries exist anymore. Hence, one of the most important reasons for companies to choose OpenStack is to be able to innovate faster than ever before. These are, for example, reasons to choose for the solution. For example, AI, machine learning, big data integration, and for example, blockchain. Companies who are looking into these technologies often have the tendency to choose OpenStack earlier than other companies. So who do we do that for? And of course, why? Yeah? We see that our customers we are doing business with are advanced companies having their own reason for using OpenStack. Just to name a couple of them, for example, the University of Luxembourg. It's a large university in Luxembourg. It's a small country near the Netherlands. And the University of Luxembourg, they uses translational medicine data hosted by big data services with OpenStack. And they first looked at VMware in combination with Oracle, but they could not reach their technical requirements with these solutions. So that's why they choose OpenStack and the fully managed OpenStack solution of Fairbanks. For example, CompuGroup Medical, it's a company based in Germany. They have a lot of customers who log into very sensitive data, and also they offer hosted services to customers from all over the world. So another one is TomTom. TomTom makes navigational software and hardware. And TomTom has a large group of developers which are active on development of application and new techniques. And because they have a lot of developers working for them, OpenStack was the logical solution to mainly spin up and break down servers very fast. So that's why they choose for OpenStack. Also, Vodafone, maybe also known in the US. I'm actually not sure, but it's a telco, a telecommunication company, and they used to set up telco-specific hardware for their services. But with the private cloud solutions of OpenStack and the broad support of network resources and speeds at the data center of Vodafone, these specific hardware was replaced by OpenStack, saving Vodafone a lot of money. So they all have their own reasons choosing OpenStack. So in the early 2018, we did Fairbanks did a market research to see why these and other OpenStack users adopted this cloud into their companies. The main reason why these companies are using OpenStack is to be responsive to what's happening in the market, but also to be disruptive was an important thing that was mentioned. To lower costs of their current private cloud environment. Stay competitive was an important point of them, and respond quickly to changing context. Also with, of course, the changes in the market and their software development. Furthermore, these companies found it very important to automate and orchestrate even more than they did at the moment. So Fairbanks works together with several vendors in the open source market, providing customers with a wide set of possibilities and support. And yeah, you see some of these companies we work together right here. And of course, LeoStream is here. And if you have any questions, please let me know in the chat, or contact me later via LinkedIn. And I'll hand it back over to you, Karen, now.
All right, great. Thanks so much for that. That was fantastic. So before I start diving into more specifics on LeoStream, let me quickly go over just a few reasons why you may want to look at expanding your private cloud into a hybrid cloud. So the first item here is really about how you fund your environment. When you use a hybrid approach, you essentially rent the extra resources from your public cloud vendor based on consumption. So those extra resources are paid out of your operating expenses, and only when you need them. The fact that it's based on need is ideal for satisfying certain types of users. So for example, if you have a workflow that tends to grow or shrink over the course of the year, then taking a hybrid cloud approach allows you to burst into the public cloud when you need extra capacity and then shrink your cloud capacity back when the demand decreases. Not only that means you're paying only for resources out of your operating expenses, but you avoid the capital expenses associated with purchasing laptops or other resources for your seasonal staff. But you can reap that cost benefit for your permanent staff as well. For example, if you work in media and entertainment and a new film project pops up, or if you're in oil and gas and need to access a high-performance compute cluster, instead of purchasing the expensive hardware for those users, basically temporarily rent it and the extra compute in the public cloud. Finally, hybrid clouds are perfect for users who work remotely. As a user roams from their office to the coffee shop, for example, you may want to restrict their access to your data center. To do that, simply offer the user a desktop hosted in the public cloud when they log in from outside of your office. Now, the tricky part there is, how do you make sure the user has access to the correct resource based on where they're logging in from? Or how do you automate spinning up extra capacity in the cloud when demand grows? Well, conveniently, that's where LeoStream comes in. Before I jump into the demo, let's look at the components that you're going to see that are in the LeoStream platform. There are really four main components. The first is the connection broker. It is essentially the brains of the operation. You install it onto a Linux machine and then configure it using the administrator web interface. In that web interface, you'll define pools and plans and policies that model the business workflows you need to implement in your hosted desktop environment. On those hosted desktops, you install our LeoStream agent. It's a small component, runs as a service on Windows or as a Java application on Linux, and it's responsible for monitoring the user's session, things like login, logout, idle time. LeoStream Connect then is our software client. It provides a login portal that allows you to turn essentially any client device into a LeoStream client. And finally, there's the LeoStream Gateway. It does two things, really. First, it provides gateway functionality for network isolated desktops. And then it also includes a built-in HTML5 viewer for clientless access. So now let's look at how all those pieces fit together. In this diagram, I'm showing my desktops and my connection broker hosted in an OpenStack cloud. It's that blue box you see kind of on the bottom right. You can consider that blue box to be a virtual private network in OpenStack. I've installed the LeoStream agents on the desktops, and I've placed the connection broker in that same network. So now the broker and the agents can communicate with each other. So now how do I allow my users to access the desktops and the broker in that private network? Well, that's where the gateway comes into play there. The gateway lives in a location where it can be accessed by the desktops in the private network and also by the user's client devices that are outside of that private network, either maybe just on your internal network or out in the world at large. In this diagram, the gateway forwards login traffic from the user's client device to the connection broker. After the broker works its magic to offer the correct resource to the user, and the user requests a connection to that resource, the gateway then acts as a tunnel from the user's client device directly to the desktop. So with that architecture in mind, let's look a little bit more at each of these four components in more detail. First, the connection broker. It's really the command center for your LeoStream environment and is the single pane of glass that you'll use to manage users and their IT assets, no matter where those IT assets are hosted. And just as importantly, it's the single portal that users go to get access to everything that they have permission to use. LeoStream's provisioning capabilities are particularly well suited for hybrid cloud environments, giving you ways to automatically provision and delete desktops to meet demand, and even letting you create schedules for spinning up and terminating instances, so you can avoid sprawl in your cloud and the large compute costs associated with that. Beyond those comprehensive provisioning capabilities, we also provide really a wide assortment of plan and policy options that allow you to model just about any VDI workflow you can think of. Like, sure, we can model persistent and non-persistent desktops just like everybody else does, but we can also do every shade in between and beyond those workflows as well. Finally, because the connection broker is the control center of your environment, it knows everything that's going on and it logs it. That gives you one location to retrieve audit-level tracking of who's using what, from where, and for how long. That not only allows you to track asset usage, but can also help you plan for capacity in the future. The second component is the LeoStream agent. It monitors the user's remote desktop session for events like operating system logins and logouts, session disconnects, idle time, and more. Now you can use those notifications in the connection broker to build rules that controls the user's session and desktop, such as automatically logging them out after they've been idle for 2 hours. The agent also has a role in the connection broker's provisioning capabilities. It's responsible for a set of sysprep type actions like updating the newly provisioned VM's hostname or joining it to the domain. Finally, the agent is responsible for LeoStream's last mile end user experience features, things like attaching network printers to the remote VM based on where the user is logging in from, or controlling USB device pass-through so you can restrict or permit only certain USB devices. Next, you have LeoStream Connect. As I mentioned, it provides login access to your LeoStream environment from Windows, Linux, and macOS devices. It's important to understand that LeoStream Connect handles the login process, but it's not in the data path of the user's final desktop connection. When the user selects a desktop to connect to, LeoStream Connect grabs the connection configuration from the connection broker, then launches the software client associated with the user's display protocol, using that configuration information. That means when the user is connected to their desktop, not only is our connection broker not in the data path, neither is LeoStream Connect. That means you always get the native performance of whatever display protocol you choose to use, and no aspect of LeoStream is a point of failure in the connection. Now, there is a time that LeoStream does get in the path of your desktop connection, and that's if you introduce the gateway. The gateway tunnels the user's connection from their client device to their remote desktop. It can tunnel high-performance client-based protocols like HPRGS and Mectine TGX, but it also provides this built-in HTML5 client I mentioned, and that actually can support RDP, VNC, and SSH connections inside of your browser. Now I make one last point on this slide, which is about rogue users. In LeoStream, a rogue user is someone who logged into one of your hosted virtual machines without going through LeoStream. Now, as long as those virtual machines have an installed LeoStream agent, your connection broker knows when someone logs in. So let's say you want to keep people from connecting to those machines. Well, in this case, you can isolate those desktops in your private OpenStack network and direct users to log in through LeoStream so that the connection is tunneled through the gateway. Now rogue users simply can't connect to the machines unless they go through your LeoStream environment. Okay, so enough about that. Let's see it all in action. So before I show you the connection broker, let me show you the hybrid cloud environment that I plan to demonstrate in. What you see here is the OpenStack environment that the folks at Fairbanks were kind enough to set up for me. So here's my project. They don't give me access to all the projects, just mine. So what you see here, I started by building up my LeoStream environment. I created a connection broker. I noticed that the only thing it has is a private IP. And then I created a gateway, which is in the same network, and I associated a floating IP with it. The gateway is my one access point into this private network. To start and kind of prime my environment, I created one CentOS machine, which includes the LeoStream agent. And then I created an image from that, which I'll then use to automatically scale up my cloud using the broker itself. Now, OpenStack is great for Linux, and it can do Windows, but to simplify my life, I built up my Windows environment inside of AWS actually. So here in my AWS region, I created a new gateway, which is going to be able to tunnel connections into this private network. And then I have one Windows machine here, which again, you notice has only a private IP address. Now here's the connection broker. This is the floating IP address of the gateway in my Fairbanks OpenStack cloud, and it's tunneling all my login traffic and my web traffic over to the connection broker. This is the main sign-in page for LeoStream. It can be used both by administrators and by end users, and it's completely customizable by you, so you can change the logos, colors, what have you. Now there's a lot in this interface, and I don't have time to do a full demo, but you can always sign up for one via our website and learn all about this interface. What I'm going to do is kind of focus on the hybrid cloud aspect. How do you use it to manage hybrid clouds? So this is the administrator interface, and it's essentially a list of menus down the left. And what I tell people is start at setup and work your way down to configure your broker. The setup section is where you hook us into all the other pieces that you're managing. Authentication servers, well, that's obviously your Active Directory or NIST servers, however you want to authenticate users. And then centers is where you hook us up to your hosting platforms. So here you see I've created centers both for my Fairbanks OpenStack cloud and for my AWS cloud. If I look at this, for example, it's quite easy to set up. For OpenStack, you give us the auth URL for Keystone v3, and then tell us the domain and the project you want to manage in this particular center, and credentials for users who have access to the APIs that we need to do things like inventory and power control the machines you have in that project. If you're managing multiple projects in OpenStack, simply create multiple centers. Similarly for AWS, in this case, I created an IAM user in my AWS account and then just entered the keys for that user. Again, that user needs only the permissions to run the particular set of APIs that we use for these clouds. As soon as you create any center, what LeoStream does is we reach out to that center to see what you already have in there. And those resources show up here in the resources page. Each of these pages are essentially laundry lists of the different things that you're managing inside your LeoStream environment. For example, on my desktops, I see all the desktops that I created both in those two clouds. And then in my images are all the images that are available for me to do provisioning for. I mentioned I had an image in my Fairbanks OpenStack cloud already, and there it is. So that's the image that you'll see me use for provisioning. It has VNC server installed and also our LeoStream agent. The last piece in the setup is simply to tell us where your gateways are. So here you see the two gateways, one for AWS and the other one for Fairbanks. After I've completed the setup, which hooks me into all my other systems, then the configuration section is where I actually define all the workflows that I want in my VDI environment. I want to focus particularly on pools. Now, pooling in LeoStream is very flexible, and it really has a few main purposes. One, ultimately, pools do indicate which desktops users have access to, but pools also contain the rules that you use to tell the broker when to provision new machines. So if you look how I have my pool set up, I have a top-level pool both for everything in my AWS region and in my OpenStack project. And then I've created sub-pools inside both of those, which are ultimately what I'm going to offer out to my users. If I look at my VNC desktop pool, here you see I have it based just on a naming convention, everything that starts with the word Linux. And on the right, you see the pool size information for what's in that pool now. Pools control provisioning, as I mentioned. So down here in the form, you see a section that tells the broker, when do I provision new instances in this pool? And there's really a couple ways to do it. I could come in and spin up a new machine right now by saying I want 2 in this pool. And then as soon as I save the form, the broker would realize there aren't enough desktops and automatically spin one up. As I mentioned, you also can do it based on time of day. So if you have classrooms that start at certain times or shift workers that work at different times, you can actually just schedule their machines to be created when they log in, when they come to work, and then torn back down when they're done. So the provisioning limits control when does the broker spin up new machines. The provisioning parameters then say how. And the how depends on which cloud you're actually provisioning into. In the case of my Fairbanks OpenStack cloud, here's where I've set my naming convention. And then down here, I give all the other aspects that OpenStack needs to spin up new instances. The availability zone, there's the image that I've selected, what flavor and network, security groups, and then finally I indicate if the machine is deletable or not. Now, that's important because if you want us to both grow and shrink your cloud, you need to tell us that this is a machine we have permission to delete. We only delete machines we have permission to, so we don't inadvertently delete something you didn't want us to. So pools control when we create the capacity. How do we know when we remove the capacity? That's done via these plans that you see next. Now there's 3 types of plans. Just very briefly, protocol plans control what display protocol we use to connect the user to their machine. And there's at least 10 or so different protocols that we support. Power control plans kind of do like what they sound. The control tells us when to control the power state, when do we shut down machines, things like that. The release plans, I find these to be the most interesting. Here's where you're going to say, when do you delete machines? How long does a user have access to the machine? If we look at this form, you'll note that it's broken into these sections. Did the user disconnect from their machine? Have they logged out? Did they go idle? These are those notices that I mentioned are coming from the LeoStream agent. And you can, again, take actions based on those. So if we look at this plan just as an example, you'll notice that what it says is, well, if the user disconnects, don't release the machine to the pool. Keep the user assigned to it. It still belongs to them. Maybe they went to lunch, they want to come back. But if they log out, well, give them 10 minutes to log back in. If they don't log in 10 minutes, they'll release the machine to the pool. Now, the thing about the sections in these plans is they actually cascade. So if my logout triggers the release event, that will then trigger this part of the plan, which is set to immediately delete the machine from disk. This plan is even more interesting because what it's also saying is, well, have the LeoStream agent monitor the user for idleness. Did their mouse and keyboard go idle? If they haven't touched their desktop in an hour, they probably walked away and forgot to log out. So in that case, forcibly log them out, which triggers the logout section to release in 10 minutes, which then deletes the machine. So pools are groupings and provisioning. Plans are sets of rules that tell the broker how to control the user session. All of those come together in what we call policies. A policy in LeoStream is another set of rules, which basically tells us which pools are we offering machines out of, how many machines should I offer to that pool, and then which plans, which protocol, power control, and release plans are associated with the machines that the broker offers out of that pool. Now, a policy can actually offer desktops from multiple pools. So I've showed you I offered one machine from my VNC pool. The same policy offers one machine from my RDP pool, which is actually in AWS, and then connects to that using the RDP protocol plan, which is set to use the gateway in AWS as well. So you create your policies, and then generally, just like most of the brokers out there, policies are assigned to users based on their member of attribute. What groups are they a member of in your Active Directory server? But one of the unique aspects of LeoStream is that it's actually not based just on who the user is, but also where they are. You can define locations and change what the user has access to based on where they come in from. LeoStream then also has this handy what we call test login feature that allows you to simulate the user's login. So after you go through all your steps, you can see what it's going to look like when the users actually log in. So I simulated my login, and you'll notice indeed I'm going to get one machine from my VNC pool and another machine from my RDP pool. So what does that look like as an end user? Well, here I'm logging in with my credentials, exact same web portal, but when I sign in, what I see are my offered machines. Again, this is customizable. You can obviously enter information into the message board, change colors. When I click connect on here, what's actually happening is the connection broker is telling the LeoStream agent on that machine to start a VNC session, and now that VNC session is being tunneled through the LeoStream gateway. And there you see me getting connected and logged in. Now what's interesting on my broker here is you as the administrator see all of this going on. The log page again has running tally of everything going on in your system. So you can see I logged in, I was offered my machines, I requested a connection, I got assigned. And now we'll notice what happened. As soon as I got assigned to that machine, that triggered the provisioning limits in the pool. And so a new machine is being spun up inside of my Fairbanks OpenStack cloud so that when the next user comes in, that machine is ready for them to use. So again, here's my HTML5 in browser VNC connection via the LeoStream gateway that's in the Fairbanks OpenStack cloud. Now, let's look what happens if I log in through LeoStream Connect. That's this client here. Do I remember my password? Nope. There we go. So now you notice I'm the same user, I'm offered the same machines. Now I'm going to connect to my Windows machine that's actually hosted in Amazon Web Services. So now this is an RDP connection that's been tunneled through the gateway that's in Amazon. So from my laptop, I'm able to connect to all these different clouds. And again, the connection broker is logging when I do that and showing all the information. Okay, we're running short on time, so let me just go back to, let's wrap up the demonstration. As I mentioned, you can always reach out to us and get more information and more demonstrations later. All right, let me hand it back to Mickel really quickly for a little bit on Fairbanks and what you can do for next steps.
Yeah, a very little bit, Karen, because we are also indeed running out of time. I think it's very interesting to see the LeoStream running on a hybrid model together with Amazon Web Services and OpenStack. Yeah, maybe nice to tell that Fairbanks also invests in events and marketing to interconnect OpenStack users in the community, to share experience and knowledge. We think that's very important. And as I mentioned earlier, we post technical articles on LinkedIn and Twitter, and also visit major open infrastructure cloud events all over the world. So maybe we will meet each other someday. If you do, I'm happy to shake your hand and get acquainted. And for engineers, we host meetup events, which are short events where we share knowledge about different technologies and processes. And also really short, we have some additional services we offer apart from our open infrastructure services. We also provide companies with software-defined storage. It's comparable with our OpenStack service program, but then only for open storage, which also uses commodity hardware. And some companies, we see that some companies see the replacement of the storage infrastructure as the first step to a fully open infrastructure. So that's why. And also an important part of our business is our hybrid cloud solutions, Amazon Web Services, Microsoft Azure, and Google Cloud. They're important parts of our portfolio because we work together a lot for our hybrid cloud proposals we offer in the market. For example, when we talk with customers about outbursting failback functionality in combination with their own OpenStack private cloud infrastructure. So it's an important way working together with the big public cloud providers. So these were the last thing I wish to mention, Karen.
Yeah, I'll just wrap it up really quickly with a little bit on LeoStream. We have been at this since 2002, so we are what we consider on a mission to be the premier platform for providing remote access to any IT asset. And really our key is to anything from anywhere on any device and really just for anyone. You'll find us in all of the major verticals that are out there, from media and entertainment to oil and gas, semiconductor design, you name it, we probably have a solution for you. But even beyond the product, the thing that makes me most proud is our team. Our level of support is above and beyond what you will get from most of the other VDI vendors, if not all the other VDI vendors out there. And we're happy to provide references for our customers who will tell you just that. And of course, if you'd like to give it a whirl, particularly with Fairbanks OpenStack, we do offer free trials, so you can find that on our website along with a link to set up a more detailed demo if you want a little more information before you dive in. And with that, because we are out of time, there are some questions, but I think what we'll do is we will email people to follow up specifically with their questions. If you do want to reach out to us, you can find us both on LinkedIn or email us questions directly. Mickel, any last words before we wrap it?
No, I would like to thank everybody for watching and listening, as you stated on the sheet. And yeah, I'm happy to answer all your questions and things you would like to know about OpenStack and about LeoStream. So that's great.
All right. Thanks, everybody, and we'll talk soon.